Thank you, Madam Chair, and Mr. Simpson for having this hearing today. It's truly an important subject to discuss. I want to thank Congressman Wasserman Schultz for her sharing her testimony today. It helps us understand the significance of what you're working on. And I won't extrapolate a lot, but this kind of work impacts almost everybody. And let me tell you, as someone who held the hand of my first wife as she fought breast cancer, even though you are coming up with new things all the time, let me just tell you, it isn't fast enough when you're in the situation where a loved one is facing something like this. So anything we can do to accelerate your ability to come up with things not just in cancer, but in brain research and all the other disciplines that we're focused on. But so thank you, all of you, for your work. It's the Lord's work, and very much we appreciate as Mr. Fleshman said, we all support doing as much as we can to further that work. So I'm from the state of Washington. I represent among my constituents are those that work at the Pacific Northwest National Laboratory. Truly a tremendous institution that does a lot of work in so many different areas. Like Mr. Simpson, I'm always amazed at the things that they're working on there, and also, I hate to admit this, but like him, don't always understand what they're doing, but it's great stuff and making tremendous strides in much of that work. So I'm proud of that, and I always try to point out what I think is really one of those things that a lot of people, even in the Tri-Cities and the state of Washington, aren't aware that what's going on right down the road. And so thanks for giving me a soapbox to talk about that. But as much of the partnership between the NIH and the DOE, as you've talked about, Dr. Varmus, it's been focusing on the world's computing systems, and I think the fastest one happens to be at Oak Ridge, if I'm not mistaken.
And the next fastest one coming.
Oh, is that right? Okay. But you also talked about other things that DOE and the labs bring to the table. My understanding is that several of the NIH programs look to PNNL for things such as the advanced chemical analysis systems that can be very crucial for understanding the impacts of, say, exercise on our health. And even like Ms. Wasserman Schultz was talking about, helping do early detection of cancer and potential treatments. So I guess that struck me as being something. What are some of the areas beyond computing that you see some of the DOE facilities and the researchers having an impact on things like cancer, or where should we be encouraging that into the future?
You're correct, Mr. Newhouse, that all of us have been emphasizing to a very large extent, but not exclusively, the computational power that DOE brings to the table when DOE and NIH undertake things together. And indeed, the cancer initiative I described is largely based on the interface between high-performance computing and certain areas of cancer research. But as we heard, and as is manifest frequently, but as we heard during our workshops in putting together a report on NIH-DOE interactions, there are many other areas: materials science, developing new ways to fabricate things; nanotechnology, the creation of very small devices that can be used, for example, in drug delivery or in delivery of radioisotopes. Those are areas of research where NIH and DOE are doing things that are similar and benefit from the interaction. You talked about sensors, and sensors can range from sensing exercise regimes to sensing molecules in the bloodstream. Please, Mr. Simpson, who alluded, or was it Ms. Captur, alluded to devices for detecting head injury. We can now measure DNA that comes from cancer cells in blood by taking a peripheral blood sample and use that as a guide for whether treatment's actually working. That's a kind of sensor developed largely through NCI and the private sector in this case, but representing the kind of sensitive device for finding just individual small numbers of molecules that can reveal the function of an important organ or the progress of disease. So these are all areas, and mainly coming from engineering and the physical sciences, which has been the strong point for much of DOE-related research, but as I tried to emphasize, has historically been involved in many of the advances we've made in healthcare, from the earliest, the development of simple X-rays by William Rankin over 100 years ago to more modern ways to use magnetic resonance imaging or PET or CAT scanning to diagnose disease early. All these represent efforts to understand the body not just as a living set of cells, but also as a physical entity made up of molecules that are sometimes best approached through physics, chemistry, and engineering.
I have perhaps a tangential answer. So about 2, maybe 3 years ago, I'd never really heard of the National Lab System. I was 100% a neuroscientist. I'd maybe heard of some national labs, but certainly not of the 17 that exist. So when I first showed up, I was amazed by the technology, the X-rays, the computing, the material sciences. But I'd like to add one other thing, which still surprises me, and I think Dr. Varmus alluded to it earlier. There's a culture about the National Lab System that doesn't exist or exists at a less prominence in academia, and that is that impossible ideas seem common in the National Lab System, and people there are willing to address things that have a scientific basis and a physical basis, but in other settings, the scale is beyond what people could imagine. And I think this culture, this part of that National Lab System is crucial and valuable. It's a place where impossible ideas are routinely considered, and that, or what are at the moment considered impossible ideas are routinely considered. And there's a different risk versus reward analysis that's happening, I think, in the national lab, in the DOE system, that's different for appropriate reasons in the NIH world, where the risk versus reward is calculated differently. And I think combining these cultures is going to actually help advance science, even if there were no X-ray sources or computational sources or material sciences sources.
Maybe I'm way over time, but that may give me an opening to ask my second question. But if I were one of your students, I'd say Dr. Bobby, but Dr. Kasturi? Yeah, okay. So I was interested in your comments, and I wanted to ask you if you were familiar with the Allen Institute in the state of Washington, their efforts on brain science. That I've just learned a little bit about some of their things that they're working on, and like the Brain Initiative and the potential partnerships with the NIH and DOE to facilitate further scientific discoveries. They've been successful on large-scale transformative neuroscience projects, including just what you mentioned, the mouse connectome, as you referred to, you talked about that. But also wanted to flag that the Institute does provide open access of the data for scientists worldwide, free of charge,
yes.
And which has partially been made possible by the congressional funding of the Brain Initiative. So should also point out that the Institute has a history of forging collaborative partnerships with other DOE centers of excellence involving neuroscience projects, such as Big Neuron Data Analysis Hackathon at Oak Ridge. And I know a lot of the great folks at the Institute look forward to more opportunities for comparable partnerships with those initiatives. So just wanted to bring that up. Any thoughts you might have on that as well?
I should say that the Allen Institute for Brain Science has some of the premier scientists in the world studying brain mapping, the way we do it. We are at worst frenemies, at best very close colleagues. I cannot imagine a kind of effort at a large scale doing this kind of mapping, not including places like the Allen Institute or Genelia Farms, as Dr. Varmus mentioned earlier. These people have great experience in how to do this. And I think it's this combination of private institutions like the Allen Institute and Genelia Farms mixing with federal institutions where we will have really great breakthroughs. But in general, both the data they collect and the way they distribute the data for free to the community is a kind of model to emulate.
Yeah, good. Thank you very much. And again, thank you all for being here. Dr. Chance as well. Appreciate your testimony. Thank you, Madam Chair.
Thank you,